Hi, Assalamualaikum. My name is Muhammad Hbsc, and now I want to present the introduction for our project. Ventilation system is a must when making a building to supply oxygen for metabolism and neutralize metabolic contaminants such as carbon dioxide and odor. HVAC stands for heating, ventilation, and air conditioning. HVAC provide for heating and cooling for both residential and commercial buildings, as well as many systems utilized to move air between interior and outdoor locations. The primary goal of an HVAC system are to maintain acceptable interior quality of air through proper ventilation and filtration, as well as offer thermal comfort. It can regulate the temperature, humidity, and purity of air within enclosed area. HVAC works in three main elements. First, as furnace as a source of warm air and air conditioner as a source of cool air. The second one is control the air distribution throughout the building via connecting pipes and ducts. And the third one is the thermostat that functioning as a control unit to regulate the whole system. Next, the objective. The objective of our study, and the first one is to explain the components of HVAC system and its functionality. Second, to find out the working flow of a complete HVAC system in a building. And the last one is to redraw a schematic drawing of HVAC system for better understanding.
Next, I will present our selected M&E system, which is ventilation system. Ventilation is the intentional entrance of external air into a space that primarily used to control indoor air quality through dilution and displacement of interior pollutants. It can be used to control interior temperature, humidity, and air movement for thermal comfort and satisfaction with other aspects of the indoor environment. Mechanical ventilation is the intentional movement of external air into a building via a fan that consists of two types, which are supply fans and exhaust fans. Ventilation efficiency of a system refers to its ability to eliminate pollutants in a space. An air conditioning and mechanical ventilation system are responsible for the regulation of heat, airflow, ventilation, and air conditioning of an entire building. The main purpose of the system is to maintain the air-conditioned space pleasant irrespective of their outdoor climate. Thank you.
The location of case study is at Jupiter Hospital, Grille, India, which has a hot and humid climate. It is a multi-specialty tertiary care hospital with 315 beds, and the total built-up area is 26,580 meters square. This hospital is using Hbsc as ventilation system. There are three components of Hbsc in this case study. First is air handling unit, which is AHU. AHU performs circulating, cleaning, heating, chilling, humidifying, dehumidifying, and mixing of air services. It also clears the outside air before mixing it with the return air and performing the necessary psychometric processes. It also serves as a heating and cooling system for a number of zones. Next is chiller. A chiller is a device that uses the power of outside air and water to maintain a consistent temperature and ensure that your industrial process is kept at a constant temperature and pressure. The last is condenser. The condenser is in charge of completing the condensation process. The duty of condenser is to drop the refrigerant's temperature to the point where it can revert to a liquid.
Based on the case study, there are three components of Hbsc that have been discussed, which are the chiller, the air handling unit, AHU, and condenser. For the chiller, its function is to generate cool water for air conditioning by removing heat from the building. The evaporator cylinder is the component that generates cool water for air conditioning. It passes via a coil within the air handling unit, which is blown over by the inside air, transferring heat from the air to the water. This allows the cooler air to circulate throughout the building. Next, the AHU works in conjunction with the chilling system to circulate and maintain the air during the Hbsc process. A commercial air handler is a huge box with heating and cooling coils, a blower, racks, chambers, and other components that help the air handler do its work. Condenser is usually outside because it uses a fan to swiftly throw cool air over its core to transfer heat from the inside of the structure to the outside environment. After the gas has been compressed, this cools it inside the coil, so it may be transferred to the air handler at a near freezing temperature. The compressor is located at the bottom of the condenser unit, and the fan is located at the top all of which are enclosed by the coil and exit through two copper pipes that lead either up the side of the building or underground to the air handler.
Good evening. Today I'm going to talk about my part, which is the designing of ventilation system. Uh, we got total of five floor, including ground floor and one rooftop. For the ground floor to third floor, the yellow color line here represent the ducting for supply air, and the X cross here represent the grill for supply air, while the purple color line here represent ducting for exhaust air, and the single dash is the grill for ducting air. And we also have other ventilation, which is natural ventilation. We have sliding door for every office room, and also exhaust air exhaust fan at every toilet. Level 4 have the same function as other ground floor to third floor, but the centralized AHU system is fixed at the rooftop. As you can see, AHU system here is the blue color line, is directly connected to ventilation, supply air, and also the exhaust air system, while the green color here is the outside fresh air which come into the AHU room. So this is the 2D view for the supply ventilation ducting, and this is the schematic diagram for the supply ventilation ducting. This side is connected directly to AHU system, and as you can see, this is the 3D view, and this is the airflow system for the air to come in and go out through the rooms. And then every these junctions got their own blower fan to supply head to push the head towards the room. So this purple color line is schematic drawing for airflow diagram of exhaust ventilation ducting, and then as you can see, the black color line is representing the air out, which is going outside to the air vent for outside and also to the AHU. And as you can see, this part is connected to AHU and this part is connected directly outside. And this is the 3D view, same as the supply vent. Every corner here has its own fan which suck the air in and then pushes to the AHU and also air to the outside. So this is the schematic diagram for AHU. The basic system inside the AHU. Yes, you can see there is dampers and pre-cooling coil, and then this is the mixing chamber of exhaust air and also the fresh air from outside. While this is the filter which filters the air, while this one is the cooling coil and heating coil, which is connected directly to the hot water and cold water system, while this is the supply fan blower. This supply fan is supposedly for supply vent, and this one is for the exhaust vent, and this one is directly connected to outside vent.
For implementation of proposed design, there are four components. First is AHU, which is air handling units. Circulating, cleaning, heating, chilling, humidifying, dehumidifying, and mixing of air are all services performed by AHU. It also cleans the outside air before mixing it with the return air and performing the necessary psychometric processes. It also serves as a heating and cooling system for a number of rooms. The components of AHU is supply fan motor, cooling coil, filters, mixing box, dampers, heating coil, preheating coil, humidifier, centrifugal pumps, control system, and casing. Second is supply grill. Supply grill was used to cover the supply vents that pump hot or cold air back into buildings. The conditioned air moved from heating or cooling system through the ducts, out of the supply vent and into the room through this opening. The third is exhaust grill. Exhaust grill is a grill through which air is exhausted from a conditioned space to the atmosphere. The exhaust grill covers the vents that suck air back into the system to be cooled or heated before being pumped back into the building. It also used to hold air filters in place and be purely functional or decorative. The last is square ducting. Square ducting is air delivery or conduits, passageways or pathways used in heating, ventilation, and air conditioning (HVAC). Supply air, return air, and exhaust air are examples of airflows that require the use of ducts. The components of square ducting is vibration isolators, take-off, volume control dampers, smoke and fire dampers, turning vanes, plenums, terminal units, and air terminals.
AHU distribute air within a building by bringing in fresh ambient air from the outside, cleaning it, heating or cooling it, and then forcing it through ductwork to the designated areas. It comprises of some dampers which have multiple rotating sheets of metal at the intake of the fresh air housing and the outlet of the retained air housing. Following the dampers, there are filters to prevent dirt and dust from entering the AHU and the building. If these filters are in place, dust will pick up inside the ductwork and mechanical equipment as well as enter the building and be breathed in by the people, making the building unclean. The cooling and heating coils are the next component to the flow. These are used to heat or cool the air in the building. As the supply air exits the AHU and enters the ductwork, the temperature of the air is recorded. This must be kept at a specific temperature in order to keep the occupants within the building comfortable. The following component is a supply fan. This will suck the air in from the outside, pass it all through dampers, filters, and coils, and finally push it out into the building's ductwork. If the moisture content of the air falls below the required level, a humidifier must be used to provide moisture to the air. In most cases, this device will either emit steam or spray a water mist into the air. If the air is overly humid, the cooling coil might help to lessen it.
Finally, we can conclude that the HVAC system for a building is very important to make sure occupants can breathe clean air and stays in the building in any condition that is comfortable. A great attention to detail must be paid while choosing an HVAC system that is perfectly suited residential or commercial buildings. The system provides a safe and healthy environment for any space. And finally, our main three objectives that we propose to achieve. Thank you.